all the spots, so if you're tuning in from home and any of these dots look close to where you are, please join us on the road. We're only going to be broadcasting the first hour and a half or so this morning.
That's right, we're going till 10:30. And so you can see the coverage. We have, you know, in North America, SAFE is largely doing it, other than we have a great partner in Quebec. And then worldwide, we have our partner network, and we have folks from SAFE joining many of them. So, so it's pretty exciting. Learn all about FME 2015.
And let's hope that in 2016 we can make it to Africa.
Absolutely.
That's the only well, and Antarctica.
Yeah.
Although there has been an FME apparel or swag has made it to Antarctica. I have a relative that works for the New Zealand Air Force, and he's worn an FME toque down there. So we've been
and I believe the Antarctic Survey has used
That's
FME.
Right. Actually, one of the first customers is the British Antarctic Survey.
Absolutely.
So lots of FME in Antarctica.
Absolutely.
Per capita.
Yeah, more than in Iceland, it looks like, but maybe not. Anyway.
Maybe not. So that's actually an old slide.
That's an old slide. Actually, it's 1650 was the number I saw.
That's
so
right.
Anyway, so you can see that's yesterday. Today was 1650. Tomorrow could be 1800. It's just going crazy.
And that's the number of people in North America that are going to be spending a day with us over the next really 10 days, because all the North American ones end basically at the end of next week.
That's
so you're
right.
the first to see this, and thank you, Vancouver, for hosting us and allowing us to kick it off here this year.
That's right. So the agenda, well, you and I are going to talk for 10 minutes, and then Mark Stokes is going to take over, and he's going to do some of the heavy lifting.
And then we're going to do our usual thing where we tour around the world, and we're going to do roughly 9 stories showing an amazing set of things that customers are doing with FME around the world. And that's just this morning. Then we'll bid goodbye, farewell to all our friends at home, and we'll continue on here in Vancouver and enjoy the rest of the day with some guest speakers from Vancouver, as well as some other talks getting into some deeper details of some new things and old in FME.
That's right. So if you want to see the rest and you're online, then come to a city near you, and then you'll be able to see all the things we're going to cover in Vancouver today.
So we thought we would just spend a moment or two reflecting on why does SAFE do what it does, and why do you use our products, and what makes us wake up in the morning and try to do things ever better. And really they break down into 3 different things.
Yep, the first things, you know, at SAFE we talk about connect, transform, and automate. And the first thing's connect. And the idea there is we believe that you should just be able to leave the data wherever it is, and then at the same time pick the best tools for the job, and just connect to that data, use that data, and not have to, you know, transform, move all the data in another system, but just be able to pick the best tools. And really, being able to connect to the data, use data with different tools, it's kind of like mining, or in this case, turning coal into diamond, which are both different types of carbon. So that's the idea. You know, data scattered all over. Just leave it where it is, work with it, extract the value from it, and that's what we mean by connect. And I think there's 300-ish, 400-ish. It just keeps going. It depends on how you count. But
I notice our friends from tech, that's what they do, is turn coal right into diamonds. Is that right, Tyson? Yeah, that's what they do. They use FME for that, actually. So the other thing is that we think that your data should be more of a liquid than a solid. If some of you were at our user conference across the street here a few months ago, Paul Ramsey talked about this. Paul Ramsey being the original founder, really, or creator of the PostGIS database. But he said prior to FME, when he had to work with data, it was like he had a great big block of marble there, and he had to get a chisel and hammer away to try to get the data to be what he wanted it to be. And with FME, the idea is instead of that, you basically can create a mold and then pour your data in there and get it to look just the way you want. So FME makes it possible for you to take your data and get it to what you want it to be without a lot of effort. And we think that provides a lot of value. And that's really the transform part of what we think is important.
Yeah. And the last part, of course, FME server, FME cloud's all about automation. We like to be able to author a workspace, set it up, and forget about it. You might have a job that's as simple as every night you need to run it, so you can set up a schedule. We're also going to see today some ways you can set up triggers. So it could be a data arrives on an FTP site. It could be data arrives in a folder. It could be an email arrives. And all those things are triggers that cause FME to automatically do something. So no longer do you have to be, you know, periodically checking manually. You just set this up, and away it goes.
That's right. So taken together, we believe that you should be able to use your data wherever,
however,
and whenever It's needed, and we actually practiced this ahead of time.
Yeah, we did last night. First time ever, and we kept arguing over who got to say the however. So
yes,
we had
exactly.
to flip a coin.
But today, as you see the various functionalities in FME, the various ways customers are using it, you can go back to this because it's about why we're doing what we're doing, and it's amazing the results that people can get. It allows you to be more productive in this work.
That's right. That's also our roadmap. People want to know what our roadmap is. That's right. That's also our roadmap. Be able to connect to more things, be able to translate more ways, and be able to automate new ways.
Yes. Yeah. So, with respect to that, today we are making lots of reference to our next release, which is 2015.1. It has a bunch of additions over the 2015 release. It'll be out in May, but we're going to be using it on the World Tour and showing some of the new functionality there. Again, the things we're adding go back to those previous slides, and we hope that it's going to make you all more productive. We're quite pleased with some of the things that are coming in there.
Lots of good new stuff, absolutely.
Now, I'm not British, and I'm not particularly a car guy, but apparently there was a show called Top Gear that involved something called a cool wall.
The show's been canceled?
The guy got kicked off for being too big of a jerk. So,
and so they just didn't get a new guy?
Well, I guess you can't. He's probably going to be on Netflix now or something. But anyway, as we go around the world, one of the things that Don and I really like about the World Tour is it lets us get face-to-face with many of you. And one of the ideas we have this year is to try to capture more of your feedback and ideas. And so I need a British person to describe this, but I think the idea of a cool wall is what? You have three, do you know what it is, Mark?
I'm British, but I don't know what it is.
Okay.
You have three columns, right? You have cool in the middle, and then you have sub-zero, which is cooler than cool.
But is that good or bad?
That's good. Oh, that's really good. Yeah.
So
and
below zero is good.
Yeah, and then not cool is, well, not as cool, not as good.
Okay, so what we want is during the day, all of you have on the tables these kind of things. So during the breaks or whenever, as you think of something or as a talk is presented, if something comes to your mind, either something you think we should add or something that we've done that fits in any of those categories, write it down during the break, stick it up there, put your name on the back, because at the end of the day, we're going to pick some off there and you'll win some of our fabulous prizes there. But don't put your name on the front because that could skew the judges'
That's right. It's not a popularity contest, remember. I have a few.
Okay, you're going to go try
Okay,
it
so yes, absolutely.
So Leslie said it. He promised he wasn't going to
The
walk off
first one
stage.
is easier licensing. So anybody, where's that one? Is that sub-cool, cool, not? Nobody wants to? Sub-zero? Okay, who thinks this is sub-zero, easier licensing?
Ted's in.
Who thinks it's just cool? No.
Like
who thinks it's uncool? Who loves the complicated licensing? Stuart loves the complicated licensing, so I'm going to put that here. Okay. I won't even say whose idea that was, but somebody yelled out in the middle. Okay. The next one, you won't even know what this is right now, but this is a plug for a future talk. A single click to turn detailed FME profiling off and on. Nobody even knows what that is. Okay, so is that uncool? Because they can move later. Is that uncool? No? Ted doesn't say anything. So is this cool? Yeah? Okay. Is it super duper sub-zero, absolute zero cool? Robin says it's absolutely. I like you, Robin. Thank you. We'll put it here for now. And then our goal is we're going to move it up. Okay. That's my goal anyway. And then just get rid of everything. Only have XML transformers. Well, time's up. No, this last one is a hair replacer transformer. And you can probably guess who that one is. So Ted likes that one too. So is that cool or is that like sub-zero? Sub-zero, yeah. I think that if we actually pull that off, that's worth more money than FME for sure. We'll just go into hair replacement. So there you go. So now we got 3 seated.
Yes.
And
so it shouldn't be too hard to top those. So anyway, your challenge is to try to top those during the day.
Yep.
If you're tuning in from home or you think of ideas afterwards, we've got 2 links there that you can check out where we're tracking these kinds of things and you can vote on ideas and so on at any time. So I think with that,
we are done. So now
we're handing it over to Mark Stokes, who's going to make his Macintosh presentation debut.
That's right. That's right.
Take it away, Mark, and thanks for tuning in, everybody.
Yeah. That's right. I'm being forced to. Thanks, Don and Dale, and thanks a lot for everybody for coming. How do we get out of this? I'm on a Mac, so I don't even know how to do that. And Laura did give me a mouse, but it's disconnected. Okay, so just we'll go for a quick FME overview, and it has become, tradition here to start the presentation with, start the day with an overview of FME and just have a look at what we've been doing. So let's do that, if I can get this thing to work. There we go. Okay, so we're going to fire up our engines and get going. Have a quick look at FME for those of you that haven't been too familiar with our product so far. Have a look at a couple of things that are new to FME as I go along, and then we'll get into some presentations on what other customers have been doing with FME. So here at Safe Software, we produce three primary products, the FME desktop, the FME server, and the FME cloud. So pretty well everything starts at the FME desktop. That's where you author your workflows. That's where many of the people, our users, stop with our product line. They just run jobs on the desktop, and that's fine. So that's our primary authoring tool that those of you that are using FME obviously totally familiar with. On the FME server side, that's our kind of enterprise automation product, and so that's where you can take the workflows that you've built on FME server, on FME desktop, and publish them up to the server, and then run those in a variety of ways, allow other people to run them, automate those jobs. That's one of the primary functions of FME server. And then FME cloud is another deployment of FME server, and that's where you can sort of automate into the cloud. And so really FME server has got sort of three deployments really: on-premise, on a traditional kind of server environment, on your own virtual cloud, or through FME cloud, which is a SaaS kind of model for FME server. Who's using our stuff? Wide range of people, and pretty well anybody who's working with kind of infrastructure maps or spatial data, and that is just growing. Pretty well anything that our product can connect to, we can start helping people with. So utilities, we got some good representations here today in the Vancouver of that. Oil and gas, government, that's probably our biggest group at federal, provincial, state, and local government. That's a really primary users of our software, telecommunications and transportation. And then we're also breaking into other areas where sort of GIS is becoming more predominant. That includes retail, people doing site location, and insurance markets. So that's kind of very interesting for us, is to sort of explore those new areas where kind of GIS is becoming more popular in those kind of industries. Well, we talk about the three primary products of SAFE: the desktop, the server, and FME cloud. But really, everything in FME is powered by the FME engine. And really, that is our core application that we put most of our development effort into. All our SAFE products share the FME engine as a common platform. The FME engine is kind of wrapped up in these different products, wrapped up in FME desktop using FME workspaces. So that's what drives the FME engine in most situations. And then you have the choice of operating platform as well, whether it's on Windows, Linux, Mac OS. So that's a really broad range of places where you can run these engines, as well as on 32 or 64-bit FME versions. So we don't call it the SAFE desktop or the SAFE server, it's FME, and because that is really the core part of the product, and that's where all the connections and the transformations are done through FME. So these are a couple of Easter Island Easter eggs that we've got showing the wide range of formats, 300 plus formats in the current release of FME that we can connect to in various ways. Transformation tools in FME now are around 400 level. So that's kind of showing there the wide variety of tools that we've got in FME to play around with and do that data transformation. And as Don and Dale said there, trying to pour your data into that more flexible shape so that you can get the best out of it, and that's the core part of that's right, yeah. There's no XML transformations in there because, well, I guess it's all based on popularity, isn't it, Don? So FME Workbench is what really drives that engine. So that's the engine enabler. So that's really going to expose the power of what we can do in FME, where you're authoring, running your FME workspaces as part of the desktop application. So let's have a quick look at what we're doing there. I am just learning how to use this Mac, but I did find out that actually 3 fingers can just easily swipe you over cleanly to a Windows machine that you can then work with there. So what I was going to do is just kind of do a quick work through with FME Desktop and have a look at some of the things we can do. So we saw this earlier on. So this is the sort of FME World Tour website that we've got going, all the locations, and that's driven from a Google Fusion table. And then what we did find out on the internet is, just having a quick look at FME Data Inspector, is a bunch of people who started doing sort of community monitoring of radiometric data. And that started out of the Fukushima disaster in Japan. And so these guys have put together, basically you can have a home-built Geiger counter and then drive around and do radiation monitoring, and that's what this organization does. It's actually called SafeCast. And so this is a partial recording of some of their data that they have. So it gives the radiation level, the units, which are the counts per minute in this case here. So we thought we'd play around with that because it's kind of interesting. They've got this worldwide data set. It's about 25 million records to date that this group of volunteers are originating from Japan, obviously, but spread out across the world with these Geiger counters, just seeing what the radiometric levels are around the place. So what we thought we'd do is just have a look at that and maybe do some statistics modeling on that. So let's play around with that a little bit. I'll just start a brand new workspace here. So I'm using the FME 2015.1, which we should be bringing out towards the end of this month. Okay, so as always, when we're starting off in FME Workbench, we can add a reader here. So this will be, I'm just going to add in a Google Fusion table that we've got there. And we can look at the parameters there. I'm going to bring in these event locations that marketing guys have put together to track where all these events are going to happen. And we can now in FME just expand that a little bit so that we can read actually what's coming in there. I'm going to throw down a tester here just to filter out the data. So we're just going to look at the Vancouver data because there is a big set of data in here. So it's just going to be, we'll have a look at the location here. And we're always expanding the different types of condition that you can look at in this tester here. And that should do that. So that should filter out that data nicely. Okay, we do have one of the things that we've added to back into FME is grid lines and guide snapping. So if you want to play around with that, you can. So you can play around with grid snapping, and if you're kind of like neatly laid out workflows, you can connect up to those as well. Okay, so that's our location for the Vancouver. We're going to just buffer that so that we can do a query. We're actually over time. This has been in FME for a little bit now. Geographic bufferer. So we're just going to pull up these geographic tools. So many of the tools in FME work within the coordinate system that you're running in, and this data isn't that long, which is a bit awkward if you want to just do some buffering. So we are adding these geographic tools into FME now. so that you can, rather than having to reproject backwards and forwards, you can just choose what units of measure you want to do the buffering in this case, and put that in there directly. So that really simplifies your workflow. So we're going to put in a buffer of a few kilometers, and then what I'm going to do is I'm going to then query the data in our PostGIS data set, which is in the cloud. It's actually, I think it's an RDS PostGIS database. So we're going to pull up a feature reader here. So this is like a database reader, but in line here, and it's going to do a spatial query based on that buffer that we've created. And so there's quite a few interesting things here that we're going to talk about a little bit later on. One of the new things in FME 2015 is this idea of database connections. So here I've got a database connection. I can add a new connection, so they're named connections. So the great thing here is if you have many workspaces that are all connecting to the same database, you can now use a connection, and then if the password changes or something, you can quickly, in the connection manager, just go and change that password, and all your workspaces will continue to work. So for those people that work with databases, this is going to be pretty handy. And if you want to see those connections, you can do that. You can embed the connections if you want to be a bit more traditional and still have that traditional kind of interface as well. So I'm connecting off to these radiation measurements. I'm doing an intersection of some sort. One of the other things we've added or been working on in FME 2015 is a bit more consistency. So the first thing is here, this used to be a big lunky wizard, so we're trying to get away from wizards and have single dialogues with expandable panels. And so in this case here, one of the other things we're doing is where transformers merge data together, we're trying to have a sort of a more consistent view of how attributes will merge together, how you'll deal with conflicts of data attributes with the same name and that kind of thing here. So you can always look for this attribute and geometry handling panel at the bottom if you're working with merging data together. So we're going off into the cloud somewhere and connecting up there. And then at this point here, we might want to run the workflow and just have a look to see that we're getting some actual results there. And so now you'll see that the counts are popping up here in these little gray circles. They're doing a bit of buffering and running off into the cloud. And you can see the real-time counts popping up there. And so what these little buttons here do, we've added this to FME 2015, is run a workspace with full inspection. So any of these nodes here that we have on the workspace, while you're kind of building a workspace or debugging it, what you can do is you can inspect those features right there. So those are all cached up now, and that will pop up into the inspector, and you can see that's the buffer that we're working with in this particular workspace. So that's going to really help people help you debug your workspaces or develop them as you go. All right, so we've just got to do a bit of unit conversion because we are working with these weird units of radiation measurement, counts per minute. So apparently, if you want some half-decent results, you've got to do a bit of attribute manipulation. So this has been in FME for quite some time. I'm going to play around with the value. Is the conditional test values that you can add to your creation of attributes. And so what I'm going to say here is basically if the unit of measure is equal to counts per minute, then what we're going to do is we're going to set a value. I'm going to do a little arithmetic thingy here, and the value will be counts per minute divided by 350. Probably shouldn't do this at home. You know, playing around with radiometric measurements is kind of tricky, so to really get real results, you probably have to do something a little bit more sophisticated. But this does illustrate also something we've done in FME for our arithmetic calculations, which I know has driven many of our users insane, and that is when in our kind of arithmetic tools, when we said something like 4 divided by 3, in the past, that used to equal 1, rather than 4 divided by 3 might equal 1.33333. So, and then if you wanted a real arithmetic result, you had to go through some hoops. So what we've done in 2015, we've gone to kind of an arithmetic model rather than a programming model, which is the former. So now when you do these calculations, everything should work okay for you. Okay, lots of okays there, and we've set the conditional value, changed the units of measure. So let's now throw out some statistics and try some statistics on this thing. We're just going to try and see if we can calculate the average value for these measurements in the Vancouver area. So we've got the min-max counts on the attribute calculation here, so that's all good. And again, we could run with inspection if we wanted to. Okay, I've just got to recover the geometry, so I'm just going to put in a vertex creator here just to get back the lat longs and create a geometry. And then we're going to go out to boring old KML. We could go out to something like ArcGIS Online, CartoDB, or something like that if we're all set up for that, but just for the sake of time, I'm going to throw in a KML writer. Okay, and so we've got to say where that's going to go. Some random spot there. There we go, and if we can spell there, and that's okay, that will work for us. I'm just going to put in the coordinate system, because KML is picky about that. All right, so one of the things we've also added, and this is relatively interesting in FME, is how you're going to create your feature type when you add a new writer. So for those of you that are really familiar with FME, you'll know that when you add a new feature type into FME, you get kind of a very static view of the data model that you're going to get. And so we've now added a tool that will change the way that that feature type, or basically the destination table, is going to be created. And so what I'm putting together here is I'm going to say I want an automatic feature type, which really means I want something that's a little bit more dynamic that I want to play around with. Okay, so I'm going to call those radio stats or something like that. Let's add a symbol to this little guy, so at least we know what it is. It's going to be some sort of radiation little thing here, that'll do. And so there's our feature type there. Now at the moment it doesn't have any attribution on it at all. And, but we are in this kind of attribute definition called automatic mode. And so when I connect that up to the results there, I'm automatically going to get the attributes that I've created in the workflow, and they're going to riffle through there. And if we change anything in the way that this is set up, we can alter some of the behavior in some of the transformers or whatever. That will be reflected right across in that feature type. So you have to kind of have less worry about what's going on at the destination end of things. All right, so I'm going to run that, and in the meantime, what I'm going to do is from little tiny URLs, great things can come. So that's the great thing about FME Server, is I'm just going to trigger this slightly bigger job that's going to run up on the cloud there, and we'll see what that looks like as well. Okay, so that's the result of this guy here. So we should be able to go in and open the containing folder. I can do that from here. So there's a couple of nice shortcuts that we've added to the feature types. You can disable readers and writers right from here. Go and look at the containing folder, open up your files right from there. So that speeds things up a little bit. Of course, we can publish this right up to the cloud if we want to do. If I can remember the password there. And we can now test to see that our connection to whatever server that we're working with is working, so that's good. And we can publish that up to an FME server and run that through the FME server environment as well. Okay. And I can just go say, yeah, I want to publish that up, and what kind of services that different people in different organizations, different users that we've set different roles for and different security can work with. and up it goes. And so if we had an FME server up and running, we could look at that and manage that. Let's have a look at what the results of that little URL that I ran here. So this tiny URL, Safecast, everything on the FME server is driven through really the REST API or some URLs. And so that's what's great, is you can either build your own nice web forms. In this case here, just a simple URL has run a job. And in this case here, it's going to bring down the full file for all the cities of the worldwide tour. There it is there. And we can open that. Hopefully that's going to pop open in Google Earth. Yeah. And so that's the average radiometric readings for all of North, in this case, Europe. And now I can't navigate on this thing. And over here in North America. We look pretty good, actually, over in Vancouver. Most of us are the same. Which is the team of our team going to Denver? That's looking pretty bad, so you want to be careful going over there. Okay, so that's a quick run through on FME Workbench, a couple of the new things that we've thrown in there. So we've been doing a lot of work. That's a big part of our job, is to try and make your lives easier, make Workbench easier so that you can really power up the engine as quickly as possible and get going there. And of course, FME server, that's the engine workhorse for us. And so that's where you run these workspaces in a wide variety of ways, through the REST API, through simple URLs, through custom web forms that many of you have put together so that you can trigger jobs. Many of you are doing data download with your data sharing environment, so that's great. So FME server is really all about automation of your jobs in various ways, delivering data to users if you're in an environment that's trying to share out data. So that might be on the internet, or it might be internally. I know the Terracin folks, Fortis, I mean, they share the data internally and deliver data internally. Also doing some data validation. And then a big part of FME server that is really, really growing, and we're going to look at some examples this morning, is around real-time data monitoring. And so that's a really exciting part for a server. I think Don and Laura are going to have a look at some of that as well. So that's a really big role for FME server. And then just scaling. So as you get more jobs and more integrated data movement jobs going, FME server is where you can scale these environments. And then, of course, the FME cloud, it is FME server, so that's a software as a service. Stuart's going to be talking that a little bit. It's got more engines driven by your workspaces. Have a look at fmecloud.com and see what we're up to there. And it's a really, really good way to evaluate FME server. If you want to we give you some free credits to play around in the FME server environment. Get up and running there with the FME server. Okay, so I think next up we're going to just plow right into some of the FME around the world events. So I think I've got the slides up for you there, Stuart. I think Stuart's going to kick off with, what's that going to be?
We're kicking off down in Arkansas with the new Geostore.
Arkansas?
Nope, state of Arkansas, so. Is that an in joke I'm missing?
They don't like it when you...
Oh. Okay. So we're going to do a series of 5-minute presentations here from around the world in a similar format that we did last year. So I'm going to kick things off down in Arkansas in the USA. So this is about a story from public state moving their architecture from on-premises solution to a cloud solution. So they have a public product called the Geostore, which is kind of it's an open data portal for their GIS data for the entire state. So they have about 2,500 items downloaded from the store every month, raster and vector data. They have about 2,500 monthly active users downloading the data. So it's a relatively popular service. I mean, City of Vancouver has a similar thing where you can go to their site and download data from their side as well. So it's similar open data portal that you see for many states and cities across the entirety of the US. So I'm not going to focus too much on what the website actually looks like. It's a fairly standard kind of open data portal. You go to the website, you choose the type of data you want to download, and then you can either download the data for the entire state, so everything for the entire state, or you can kind of do more complex downloads that use an FME server, and that's, you can choose the projection, you can choose the format you want, you can choose the area of interest you want. So that's kind of the website they built. This is a new website they have. You can go to geostore.com and see the website. What I'm going to talk about is the story from them moving from an on-premises solution to a fully cloud solution. So they came to us last June, July, and they basically said, we need to move our entire stack from on-premises to cloud for two reasons. One is stability, and the other is basically they've been told to do so. We're seeing this more and more. They're basically mandated normally due to cost that they need to move to the cloud. So they said, if you don't have a cloud solution, then basically we're going to stop using FME technology. So fortunately, we had FME Cloud in beta, and these guys like to live on the edge, so they decided to jump in and use FME Cloud. First thing they had to do is move their data to the cloud. So they have 300 vector data sets, and we migrated those to PostGIS, which uses a relational database service, which is basically a relational database as a service that Amazon provides. Fortunately, we had just the tool to do the migration from SQL Server to PostGIS, which was, of course, FME Workbench. So we built the workflow to move the vector data up there. We then had to move about 3 terabytes of raster data from on-premises, just from a disk, and we moved that up to Amazon S3, which I'll talk a little bit more about this afternoon, but it's kind of cloud-based storage for files in a simplistic term. We also then had to move some historical raster data. So the first thing we did in all these projects is you have to get the data up there, work out how you're going to get the data into the cloud. You really do need the data in the cloud when you're using FME Cloud, because it needs to be close to the data does FME Cloud, or the translations are too slow. So this is the architecture that they kind of came up with. I hope you can see this. Before, what they had was an FME server deployment on premises that was clustered. They had multiple cores running in a failover scenario, and they used a SQL Server database. They had real problems with the stability of the hardware mostly. The hardware kept failing, and they were basically at a point where the service was going down every week. So this is the revised architecture. So you can see kind of there's the inner box there with AWS on it. That's Arkansas's own Amazon account. So they have all of their data in their own Amazon account, and they also hosted the web server as well. So that WordPress website is all hosted on the cloud. Then they used FME Cloud, which is on the right there, to do all the processing. Now, FME Cloud is actually on Amazon as well. So, you know, that was a very, very good relationship. We get very fast data transformation. And then we had the storage. So the storage, all the vector data was in a PostGIS RDS database, and the raster data was on S3. And so the key was we also stored the raster footprints with links to the data in S3. So rather than querying the raster data on S3, we queried the vector footprints in the PostGIS and pulled in the raster data into translation and delivered it back to the user. So the benefits, this is from the client, not from us: stability, security, simplicity, and price. So using Amazon's architecture, we have much, much higher levels of reliability. And FME Cloud, we monitor everything and look after everything. AWS compliance is extremely secure as Amazon. The CIA use Amazon now. And FME Cloud leverages that AWS security. And also we add to that, we do penetration testing. We hire consultants to test everything. The key thing they said to us, though, is they can focus on the problem, not the administration. But the price, I'll leave you with this. This is the price comparison on-premises deployment versus cloud deployment. They did the numbers. So the 3-year cost for on-premises is about $300,000 they worked out. And in the cloud, it's about $82,000. And not only the cost difference, there's the intangible costs as well, the hardware maintenance time, the staffing costs, and also the fact on-premises isn't scalable. So my time's up. I've run out of time there, so I'm going to pass the book on to Laura, I think, is it, or Ryan? I was going to talk about orchestration.
Okay. So hi everyone. My name is Ryan. I'm going to talk about talk a little bit about some work that Aleander did to migrate Oracle Spatial and Esri Geodatabase into SAP HANA. Aleander is the largest Dutch grid company serving over 3.5 million customers. They operate energy networks which distribute gas and electricity to large parts of the Netherlands. With their work, they facilitate businesses, homes, transport, and recreation. Always alert to new technologies and trends in an evolving energy landscape, Aleander uses living labs to experiment with solar, wind, and biogas innovations, network digitization, and intelligent network applications. Aleander is front-running on smart grid analytics. Aleander was looking for ways to automate loading data from Oracle Spatial and Esri Geodatabase into SAP HANA. With the SAP HANA platform, Aleander analyzes massive amounts of data to better maintain assets, optimize its grid, and help customers save big on energy bills. There was a desire to reuse software that was already in use in other departments, and FME was already in use in the GIS department. FME could also accomplish the complex spatial handling that was required. So could FME do the job? Spoiler alert, yes. The key feature in FME required for this project was our new JDBC Java Database Connectivity Writer. This new writer can support writing to any format that has a JDBC driver available. This gives FME cross-platform support for databases such as Microsoft SQL Server, DB2, Netezza, Teradata, and of course SAP HANA, amongst others. The only other real requirement was to convert the geometry into well-known binary, which is very easy to do within FME. And the end result is this. This is a demo application running on SAP UI5, running directly on SAP HANA's XS application server. In the bottom left corner, you might be able to see that there is a distance query between pipes and buildings, and that query took 3 seconds to execute. This is compared to 3 hours with Aleander's old spatial database. Since HANA is such a fast database, Aleander didn't want their ETL tool to be a big bottleneck. So they were happy to see that FME was the fastest GIS ETL tool that could load data directly into SAP HANA. And they hope that it'll get even faster in the future. So in the final analysis, FME was able to complete the data load into SAP HANA about 2.5 to 3 times faster than any of the other tested alternatives. FME also allowed the process to be automated and handled the required spatial transformations while allowing the same software to be used across multiple departments. And that's it. I believe it's back to Dawn.
So I'm going to talk about another one about FME Cloud, and in this talk we're going to look at the elasticity of the cloud. One of the great things about the cloud, of course, is that since we don't have to buy hardware or resources, we can just scale them up and scale them down as needed. Now this picture here shows lightning in Saskatchewan. That has nothing to do with my talk. So But this, the customer Pelmerex, if you came to previous shows, you would have seen them talk about how they're using FME for real-time lightning. So it's a great picture, though. So anyway, so here we go. So in this project, Pelmerex receives massive amounts of data several times a day, every 12 hours. And it's forecast data. It's forecast data, ECMWF. It comes from Europe. Anyway, it's medium forecast, so it's from anything from a few hours up to 10 days out. And so when they get this data, they want to process it as quickly as possible to distribute it to their users. So the data has a number of things: precipitation, sea surface temperature obviously has some impact on the forecast, ground temperatures, wind speed, and things like that. So they want to grind this data up. It comes in the GRIB format, so gridded binary, and they want to produce 880,000 tiles in a raster pyramid structure. Okay, so since the data is coming every 12 hours, you don't want to spend 8 hours processing it or 12 hours processing it. You want to process as quickly as possible so you're getting this up-to-date data. So each time they got this required 80 hours of compute time. So, and they, whatever that means. That means that, and these are big processors, so they need a lot of compute power. They have 10 engines on premise, and so basically they did some calculations with their 10 hours on premise. Assuming they're doing nothing, they're still looking at 8 to 10 hours to process. But of course, they already have all that system busy. So they would have to purchase a lot of new software that would, to turn around quickly, spending most of its time just doing nothing. So what did we do? They came to us. They're a great partner, and they know the cloud's elastic. FME Cloud, out of the box right now, is you buy a certain size, and that's kind of it. So Stuart and I sat down, and we came up with an architecture, and Stuart built it. I'm the cheering section. I go get him coffee, ask how it's going, give him a hug every once in a while when it's not going so well, that sort of thing. And so what we did is we were just at the Amazon conference, and there's some interesting services out there. Lambda is a brand new one, and S3. So what happens is, I'll go to the next slide. Yes. So what happens is all this data arrives every 12 hours and is put into an Amazon S3 bucket. So that's the storage service that Stuart talked about. Now the interesting thing is S3 has this capability. Whenever a file, or they call them objects, is completed, then a trigger is sent and an action can happen, and that's brand new. And so what Stuart did is when data arrives in this bucket, a trigger is sent to this other service called Lambda, which essentially runs a very small amount of JavaScript. And what this JavaScript does is, you can see there is, oh, a new file arrived. Okay, do I have any of my cloud infrastructure running? If the answer is no, then the Lambda fires up all these cloud instances. And it fires up 5 of the biggest cloud instances that are available in FME Cloud. And then it puts the file into an SQSQ. Because remember, they're dumping just tons and tons of files. Each file is going to appear, and the first one's going to cause the whole infrastructure to launch. The rest, since it's up, are just going to be put in buckets. Okay, so that's essentially what it does. So the Lambda script itself is very, very simple. And then all the messages of the files are put into another queue. So basically saying, hey, process me. Okay. So what happens next is, as a cloud instance, time's up. I barely got started. Put that away there, buddy. Okay, so what happens is, as the data comes into the queue, when these instances come up, there's 40 engines. They're all running exactly the same workspace. Each workspace grabs the job, processes it, and then pushes it up. He doesn't travel on the East Coast. And then pushes it back into the output bucket. And then at the end, when the whole processing's done, the servers, through the API, they shut themselves again. So basically, at the end of the day, this costs them $80 a run, or $58,000 annually. If they had to do it themselves, it would be 10 times the price. $300,000 for FME server, and then of course they're going to have to buy big hardware. It's going to have to be fault tolerant. They're going to have to buy big bandwidth, and easily they're looking at 10 times the cost. Also, if they decide, hey, we want to process this in an hour rather than 2 hours, they could spin up 10 of these instances, and it's still going to cost the same price because you pay per hour. but 2 hours what they wanted, and so there you go. So that's the end of that one. So thanks.
Hi, my name is Natalie, and today I'm going to overview the Thames Tideway Tunnel, and it's from Conrad, who is with Critigen. It looks like one of our Minecraft fellows is going for a swim in the Thames River, so hopefully it's not too chilly. The Thames Tideway Tunnel is a new proposed sewer, which would help with the overflow of the old Victorian sewers in the UK capital city of London. That would help to protect the Thames River from pollution, mostly from the surface runoff. It was desirable to put this model of the sewer into Esri City Engine, as it has a web viewer, which would be accessible to many users, and it wouldn't require the users to have specialist GIS software. It also would be possible in the web viewer to have other geospatial information, so it could be compared to the existing environment. The 3D tunnel and shaft elements were created in MicroStation, and so the source data consisted of MicroStation having the geospatial referenced in the proper location as well as attributes, and then Collada was used for the 3D geometry, somewhat as a interim format. As the Esri City Engine does not support MicroStation and Collada data, it was necessary to transform the data into Esri multipatch. There are a number of steps required to transform the data into Esri multipatch, the first being georeferencing, so taking the 3D Collada data and putting it in its proper spatial location. This was accomplished by taking the CAD and the Collada data and generating bounding boxes, and then the center point of the bounding boxes were calculated. The X and Y values of the center points were compared from the Collada and the CAD, and then that difference was used to shift the Collada data to its real-world spatial location. Another factor was attribution. As the Collada data only contains geometry, it was necessary to map attributes from the CAD onto the Collada data. Some of the attribute mapping was fairly common by using like an attribute renamer or attribute copier transformers. Others was more complex. For the more complex mapping, how they handled that is that for the Collada features, they created a list, and then the list was sorted, and this was referred to as the unique sequence number. Using this unique sequence number, as well as an attribute on the CAD data, they were able to map attributes from the CAD onto the correct Collada features. Sometimes the Collada features were complex, and when deaggregated, the attributes may have been merged onto the may have been merged in the wrong order onto the Collada features. So in this case, they had to take the resulting Esri multipatch and review it, and then map the attributes manually. One of the last steps in the migration process was to set a homogeneous color for sets of related 3D elements. So as a result there's this set of Esri multipatch feature classes representing separate 3D objects. And the workspace allows for a reliable and consistent way to take the CAD data and then using Collada as an interim format, change it into Esri multipatch. And then this input of Esri multipatch can be put into the Esri City Engine. And then with a little bit more processing, it can be put into the City Engine's web viewer. And then in the web viewer, numerous users can access it. The model can be compared to the existing environment, and other information can be combined. So now we're going to hear about Mount Vernon.
Thanks, Natalie. In this audience here in Vancouver, when I talk about Mount Vernon, you probably think I'm talking about some kind of outlet mall north of Seattle. But in fact, I learned that Mount Vernon, for people on the East Coast, is the historic home of George Washington. And as part of an ongoing effort that the National Park Service is doing, they are attempting to capture and recreate digitally every building of historical significance in the parks in an archive so that they can be preserved for all time digitally. And so this story is about how that work was able to be leveraged into some other applications. So again, George Washington's house, constructed, that can't be right. That must be George. Okay, I got to check on this slide because George Washington actually, it must be. That's right, because he was around in like 1776, as far as I know. So it must have been made if he lived there, 18th century. That would make more sense. Okay. But anyway, the Ladies Association has been tasked with keeping it good, and at some point in the past, it got turned into a national park. And so what was going on here was that they did an intense LiDAR scan of the whole thing, both inside and out, and then brought that into Autodesk's Revit tool, which is, at least in North America, the leading, one of the leading BIM, building information model tools, and crafted into a real model. And for those of us that have been in the mapping industry for a while, we remember when CAD used to be used to make maps. BIM is really fancy 3D CAD, I would say, and with a rich data environment available to people that are modeling in it. So it's great for capturing and describing what is built or should be built. In terms of analysis and other things you might want to do afterwards, that's where it isn't really the greatest thing. So it's a tool for capturing, and that's what they did, taking the scans and making it. So what they then did inside Revit was geolocate it. So normally architects believe the world is all centered around 0, 0, which puts it all somewhere off the coast of Africa. Which incidentally, I just was listening to a podcast, and if you buy a drone, many drones have a fly to home function if they get out of radio range. And if many of them, the default is 0, 0. So if you don't reset it, that's what somebody thought. They should just set up a boat at 0, 0 and collect all the drones that come in there. But we drift off of our Mount Vernon story. So anyway, the idea of this was that they used Revit to not only craft the model, but then shift it and locate it at the right place. And now here's where FME's role comes in. In this story, FME is more of the bridesmaid than the bride, so we're sort of the supporting role. We get to export the Revit data and then bring that Revit data, or more correctly, a subset of it, into the GIS. In this case, they used the data interoperability extension, which is a subset of FME sold by Esri, but the same stuff can be done with Esri. And once they're in the GIS, they reconnect all the attribution, and now you've got a subset of that model inside of ArcGIS in 3D, and you can start to do things. And so one of the things you can do, this is inside of ArcGIS Pro, is place that model in its context. So the trees and things are all coming from other places. The building is what came from Revit, the buildings in this case. And you can also start to do things like make sure that those condos being built across the river aren't ruining the view that George had. And so they are literally ensuring that that view out of the top of the house remains as it was. So you can't go and cut the trees down across the way. And this is a great way to simulate that. I know in the Vancouver area, our friends at the City of Vancouver, Dan Campbell in particular, has done lots of work trying to preserve the view sheds. And if you hear him ever talk, it's interesting because it actually goes across international boundaries. There's places in Vancouver you can see Mount Baker. You need to get the data from Mount Baker to do that analysis. But in this case, just across the pond. I've never been to this place. Anybody been to Mount Vernon, Washington, D.C.? How about Mount Vernon, Washington? So there's been a few to that. Okay. So anyway, the thing I think that really drives this home is the value you get when you have this model to start to do planning with it. And it turns out that this model is so accurate. Let's see if I've got a mouse here. No, let's see. There we go. There's plaster here that I don't know if Harry Truman had some wild parties or what, but they had to replace some plaster in the 50s. And so they've got this located, and they're trying to upgrade this place to do have sprinkler system in it. Well, they're going to wreck Harry Truman's plaster instead of George Washington's. And so they can plan that way. And they can turn off the roof here and see into the rafters to help them with that planning. So there's a good use. So short of it all, FME being used to leverage the data that comes from the detail-rich BIM and use it in a GIS then ultimately for purposes that are far different than what is traditionally used for BIM. Pretty exciting to see that being used. And that's all for me, and I don't know who's next. Must be Dean. Take it away, Dean.
All right, thanks, Dale. If I see the 5-minute sign, or the timeouts sign after my second slide, then I know his clock's fast. So I get to talk about something that kind of comes from my secret life before XML. Don might raise Don's eyebrow to hear about this, but before I was deep into XML, I used to do a lot of stuff with raster, so I'm particularly excited about this talk.
Not as excited as you are about XML.
Well, yeah, of course. So the whole goal here is that the Ordnance Survey, what they wanted to do is to come up with a more efficient way of updating their digital terrain models. And typically the input they have is on the left, and what they want to do is be able to remove things like buildings and get a nice smooth surface like you have on the right. And the traditional DTM generation approach was fairly manually intensive and expensive. And what they wanted to do is be able to take their aerial imagery, and there's a process called dense point matching, which when you have overlapping tiles, you can actually derive a point cloud from those. So they have this elevation point cloud, but it includes all the buildings, and so they need to be able to classify that so that they can get that enriched point cloud and get the smooth terrain model afterwards. So this is what the input looks like once you've had those overlapping tiles. You get this, gray digital terrain model. In this case, it's just a raster DTM. And so what the goal is how do you remove those vegetation features and those buildings? Okay, so basically what they wanted to do was they realized that if they could only combine the DTM data with RGB color information, that would allow them to really bring out where the buildings are and vegetation and remove those more easily. And so this is just a snapshot of one part of the workspace. I just want to highlight two things. So first of all, the data inputs are the geotiffs. So there's a geotiff for the orthophotos and the geotiffs for the DTM input that came from the overlapping tiles. And the first transform I'm going to highlight is the raster expression evaluator. So this is one of the most, I guess, perhaps underutilized transformers. Maybe a show of hands. Who's used the raster expression evaluator and will admit it? Okay, good, good. So it's a very powerful tool for doing essentially raster algebra at the cell level. So if you've got two grids that are the same dimensions, you can multiply them, add them, that sort of thing. In this particular case, all they're doing is taking the 3 bands from the RGB and then adding an elevation band to it, so making a 4-band raster out of it. So the RGB bands don't get any elevation. They get what are called color components. So you get red, green, and blue on every single point. There's these 3 component values. And then the elevation comes on the 4th band. So that's what comes out of the raster expression evaluator. And the other transformer I'd really like to highlight, and this was educational for me, is the point cloud combiner. Now, in the past, I've used point cloud combiner mostly like a mosaicer, where you can take different tiles of point clouds and combine them together. But when you go home and download the latest 2015.1 of FME, open up the point cloud combiner transformer, you'll see there's a whole raft of new functionality built into that. And aside from, of course, our XML parsing stuff, which can parse any XML, I would say this is one of the most egalitarian transformers, because you click on the docs and you look at input, and it will accept anything. So you can throw anything in there, short of perhaps non-spatial data. And raster data will get converted directly to point clouds, and vector data, you give it a grid size, it'll convert that to point clouds. So what the output from the expression evaluator goes into the point cloud combiner, and here we get this enriched point cloud with both elevation and color information. So this is kind of a logical workflow of what that looks like. So the ortho from the top, the DTM on the bottom, and those getting combined by the raster expression evaluator. The other point to make here is that the output is LAZ, and so that allows them to get about a 5-to-1 compression on their point clouds. So normally their output would be, let's say, 2.5 gigs, and now it's only about half a gig. So that's basically it. I see my time's up. So basically you get a colorized point cloud out of it, and sorry for doesn't come through that clear here, but that allows them to more easily classify the data, and it also allows them to pick out if the different automated classification routines are working or not. And the ultimate result is this bare earth terrain model. So let's see who's up next. Off to Oklahoma.
Thanks, Dean. I'm Robin, and I'm not talking about cows either. But we can't have a conference in Vancouver without talking about pipeline risk. And so this is a talk from Oklahoma about natural gas pipeline risk as opposed to oil pipeline risk. Okay. So this talk was put together by a couple of fellows who work with Access Midstream, who are a provider of gas throughout North America, and they put together a process in FME to figure out risk analysis for pipeline incidences, and they were recently overtaken by Williams, who have 33,000 miles of pipeline infrastructure across North America. So they want to, between Access Midstream and Williams, they want to put together this FME process to analyze the risk for all of those pipelines. They even have a little bit coming down from Fort McMurray into a tiny place in Alberta called Redwater. So how they analyze for pipeline risk, and they actually can get it right down to very small sections of pipelines. So, and the risk is the probability of failure times the consequence of failure. So they have a way of calculating consequences based on the type of risk that occurs. They want you to think of pipelines' probability of failure as being incredibly small, and they talk in numbers like 1 times 10 to the minus 6, or 1 in a million chance of a pipeline issue, because they say steel pipelines are designed to withstand an incredible amount of force. But what can cause a pipeline to fail? And so there's a number of, they evaluate 10 major threats. So internal and external corrosion, landslides and earth movements, that kind of thing, somebody hitting the pipeline with a backhoe, which we've seen happen around here, and then weather and other outside forces. So as you can see here, most of their pipeline is low risk. There's a few little red spots there that are high risk places. So to do good predictions, they needed an awful lot of data, and they run something called a smart pig through their pipelines that takes a look at the pipelines from the inside. And along with that, they use an awful lot of external data to pull it together. So this is what their process looks like. The spatial processes in the middle there is basically FME taking data from all kinds of different sources. So pipeline attributes themselves, the one-call data where people are trying to dig, what equipment they've got around about it, and in particular structures around that pipeline, because that's also very important in terms of analyzing risk. And then they pump all that data through into their risk analysis model, which has got a lot of SQL code that works on corrosion and mechanical engineering formulas that are all designed to produce probability numbers and that kind of thing. Once they've done all that, they then produce layers that they can actually put out onto an ArcGIS map so that they can have internal people looking at the data and external people, well, I don't know that they let the numbers out, but anyway, internal people in their own offices looking at pipeline risk factors. So they gathered the data at 4 different levels, so at quite a high level over the whole network, broken down to a single pipeline, then largest sections of a single pipeline, and then incredibly small sections of a pipeline. And you may not be able to see very clearly, but in the bottom photo at the right-hand side there, they've actually got data about each segment of the pipeline, probably where every weld is joined. It's incredibly detailed data. So this is what their workspace looks like. It's got a huge amount of transformers in it, which they've converted into a lot of very tidy custom transformers. So it has 32 readers, 10 writers, 15 custom transformers, which incorporate 274 transformers. So heck of a workspace there. So they take those 10,000 polylines that are the large pipeline figures and convert them into 200,000 polyline segments that they can calculate risk on. So that's an incredibly fine detail. And it converts, also reads in this tabular and non-spatial and spatial data that they can put it all into their risk engine. So some of the kinds of data that they get are things like lightning strikes, or tornado strikes in this case because they're in Oklahoma. So the second panel across the top, I can't seem to point to it, but the second panel along the top with the red, green, and yellow, that's tornado strikes and areas around a tornado strike. They've also got high-risk land use areas. So down here on the 3rd row, they've got drinking water zones and lakes and rivers, that kind of stuff, so environmentally sensitive information. They also pull in information from where pipelines cross from other companies, so where their pipeline might intersect with somebody else's. And of course, structures, what particular buildings are in the area around the pipeline. So this is what the smart pig looks like. So this is the thing that runs down the middle of the pipeline, and it finds issues with the pipeline. Now it's also able to tell how far along the pipeline it's going, so it's got a georeferencing component to it. It also has an odometer. It's got accelerometers and slope analysis things, all kinds of stuff going on in that piece of equipment. So as it runs down the pipeline, it can find defects through the length of it. So you'll see this particular pipeline has got 2 defects. There's a metal loss at a metal loss point, and there's also a metal loss point at a weld. So both of those are considered defects, and they've been identified by this thing that runs down the pipe. The grey buffer area is a 280-foot impact radius. So that's the area that they figure will be impacted if there's an issue at the pipeline at one of those spots. And then they've also got these structures. Obviously, there's a bunch of houses or something nearby to that particular pipeline. So in terms of trying to calculate the risk for these particular parts of the pipeline, all of this data comes into play. And so each one of these houses, they've buffered out 285 feet as well. Sounds like you need to live a bit further than 285 feet from a pipeline. But they've buffered them all, and then depending on how many buildings are impacted within those buffers, which is the numbers along the line, so they've got 10 buildings at the bottom, but only 1 building up towards the top, is how they can calculate risk. So obviously the bottom section where there's more of these buffers close to that metal loss is more high risk than a bit further up. And at the very top, of course, there's no buildings, so we're out of the high risk zone. So all of this calculation is done with FME, resulting in a final output that can be used in a risk map such as this. And all of the layers in this map have been produced from FME out of their ArcSDE, and they're using ArcGIS Server and another product called GeoCortex. So here's a map showing the pipeline in the middle, the various points of identified issues such as weld, metal loss, and then the buffer around it, and the buildings that might be affected by that if there's an issue around that. So actually, having reviewed this, it all made me feel quite a lot more secure about our pipeline industry. But it's certainly, they're examining pipelines at an incredibly small amounts of length. Okay, so that's it.
So I'm the guy holding the sign up at the back, which is kind of a thankless job, but it means you can have the sign up here and nobody can tell you when to get off stage. And I've now secured a 10-minute slot to drone on and on. Oh, speaking of drones, that's what we're talking about. Okay, so this is a story out of Finland. That's why we have this picture of snow, because I guess Finland is always in the snow. And Sharper Shape is a company that produces a solution called NextEagle. And NextEagle is a tool or a solution that allows you to be more effective at managing corridor vegetation. So there's these utility companies that string up these transmission lines through the forest, and they cut down all the trees, make sure that nothing's touching the lines. But of course, trees don't know any better, and they just grow up, and eventually they touch the lines and cause all kinds of problems. So NextEagle allows utility companies to detect when there are vegetation issues that might impact their lines. It also allows them to automatically prioritize and visualize the data as well, the actual problems. From NextEagle, once they do that, they can then create plans and they can create orders that they can then, the utility companies can then just give straight to subcontractors to go along and say, hey, go and clean up this vegetation. Using this solution, I'll talk about the details in a second. Using it, they detect 3 to 5 times more issues than a traditional method. And another thing about being able to prioritize, I'll talk more about prioritization, but allows them to work on need-based management rather than sort of scheduled, cyclical, you know, go out there, this area is due to be cleaned up. Now they can look specifically at the problems and work on them. So they use drones, they use UAVs. This is their Eagle, and it's a beyond visual line of sight flying device, so you can send it out and you don't have to see it basically. It'll go out, it'll fly the line. It only flies up to 1 hour, so there's no way it's going to the coast of Africa or anything like that. It'll only go 1 hour. But it comes back. What it does is it scans all the lines with LiDAR, sees all the vegetation, that sort of thing, and then it comes back home. So where does FME play into this? FME, there's a number of ways, but the first thing they do is they want to give the UAV the flight path. Where should it go? So to determine that, they take the elevation information off a DTM, drape the transmission lines on top of that, and then some algorithm inside of FME they've designed will say, hey, this is the most cost-effective route for the UAV to fly. They upload that to the UAV, they push the button, the thing goes and flies off. It comes back and gives them their LiDAR data. And so FME also does a number of other things, such as extracting those transmission lines out of customer systems. So there's a variety of customer systems, and FME can handle all these different systems to pull that information out. Also, the LiDAR itself is a final product in some ways, but they also, some clients have asked for cross-sections, and that's what you see on the bottom here. Can you give me a cross-section of what that LiDAR looks like? I want to see my lines. And so FME can produce basically just raster images like this. And then for the work orders they generate, they create PDF maps of the areas that need to be worked on, and that's done with FME as well. Prioritization is huge for these guys. They have hundreds of thousands of vegetation issues that are detected, and not all are created equal. And they don't have, of course, the budget to do all the issues, so they have to prioritize. And using this detailed visibility that LiDAR offers, they can, well, NextEagle automatically determines this is a serious vegetation issue. If you don't deal with it, there will be an outage. And what that allows them to do is focus on the most important areas, and they've reported that can reduce your power interruptions by 3 to 5 times. So this use of LiDAR and scanning gives you that ability to focus on what's most important. And here's an example of their Sharper Shape's NextEagle web viewer, and you can see this is one of their work orders in a web form, so you can go and check that out, and then if you want a PDF, you can get a PDF of it. And so it's almost counterintuitive to think that using LiDAR and UAVs and all this other stuff would be cheaper, but it is cheaper because you're able to detect more issues, but you're also able to focus on the biggest impact issues as well. This tree will definitely take out this power line. We go clean that up. We save money, and it's cheaper and it's more effective, and it's pretty interesting too. All right, so Now we're on to data migration at Irish Water. And Mark, you're going to do one or two, are you?
Depends how much time we got.
We'll see what happens.
Lots of time. Oh, lots of time.
I got this again too.
I want to keep people away from the coffee at the back there in a few minutes. Okay, so this is a story about Irish water. This image here is a picture of the cliffs of Moher in Ireland on the west coast. They were also appeared in one of the Harry Potter movies as the Cliffs of Insanity. So that's an interesting thing. So there's a lot of FME insanity going on today, so that's great. So this enlightening talk is about some work that Patrick Daly did with quite a big team at Irish Water to migrate a whole bunch of data across. And so what happened is that Irish Water was formed in 2013. It's an agglomeration of about 34 local authorities. They wanted to bring all the water management in Ireland into one umbrella organization. And so this, the picture on the left there is, shows each of the different water authorities. I think it's color-coded by the quality of the water for brewing Guinness or suitable for a distillery or something like that. And so what they were hoping, I guess, is that by blending all these local authorities, they could brew Guinness anywhere in Ireland. But anyway, so they're bringing together all these local authorities. They've got about 80,000 kilometers of pipe for the fresh water and the sewer data in there. And so that all has to be merged together. So this just shows you some of the statistics about the amount of data they've got. It's well over 1 million entities that they've got to bring across from these different local authorities. The data was in a product called CIS. So that was some sort of bespoke product. I forget what that actually stands for now. But it was a custom-built water management system that many of the water authorities in Ireland used. But they were all using different data models. Some of them were also using MapInfo. And so that had to be brought together into this one common data model. They decided to use the ArcGIS water utility data model, which is fairly complex. So this is a complex job. And actually what most people who start on these traditional migration projects don't realize is that most of the work revolves around mapping the data model from your source data to the new data model. That's a huge amount of effort that is required. It's got nothing to do with FME. You have to build this complex crosswalk table that says feature A, which might be a freshwater pipe, goes into this kind of pipe on the destination side. And to do that for 34 different data sets was a pretty complex job. And so a lot of data normalization going. In total, the amount of FME processing at the end of this was about 15 hours worth of data processing. So the end result was Irish Water in the ArcGIS enterprise data model, so that they had this very cohesive model across Ireland of all their fresh and foul water, as they call it there. The whole project was completed in 9 weeks, which is pretty incredible. It's a pretty decent sized team there, you can see, of all the people that participated in this. But a really complex data migration project, 34 different data models going into a single one. They felt at the time that the whole project wouldn't be achievable if they hadn't used FME to migrate that data across. So that's, I think, a really pretty cool illustration of improving the productivity of an organization for a one-time job. They're never going to have to do that again. And then I'm subbing in for one of our team members here, Brian, who's been struck down by some sort of virus. So I'm just going to wrap up the morning, and then we're going to take a coffee break and then get back to some other projects. So this is a project from a very prolific FME user, a group in the province of Rioja in Spain. Do a lot of really interesting work at FME. This is a picture of some monastery in Rioja. But the last time we presented some of their work, they do loads of very interesting stuff. We presented some of their work on some PDF reporting that they do. And one of their guys, Alejandro, I guess is how you pronounce his name, said, but don't forget to say how good the red wine is in La Rioja. So I guess that's where the province gets its name. It was only formed as a province in 1983 or something like that. So I guess they're pretty proud of their red wine. So this is one of the projects they've been doing with FME is to serve up web mapping tiles. And the goal here was to produce a an efficient web mapping tile cache at a whole bunch of different zoom level ranges. So what they also had to do is beautify those images as they went out into the tile cache. So they're using Mapnik to do that. Mapnik is an open source tool for symbolizing and adding nice things to maps, text as well. And we've, in FME, in 2014, embedded the Mapnik tools into FME as the Mapnik rasterizer tool. So that's what they're using. They're using the Mapnik tools embedded in FME. So what they're doing is they're taking a wide range of data inputs from all the data that they collect in the province, the raster data, a bunch of vector data, text labels that they have in their GIS platforms, and then they're pushing that across through to these web map tiles. They're using in FME the web map tiler, so they're producing Google compatible web map tiles. They have a different workspace for each of the different zoom levels. So the Mapnik rasterizer is tuned to produce the kind of symbology and text scales and all that sort of stuff for each of the different zoom levels that will appear in the web map tiling. So they have a different workspace for each of those different zoom scales that they're working with. So quite a lot of effort going into producing those workspaces. There's a lot of detail that you can put into the Mapnik rasterizer on the symbology side of things. So they've done all that work, and then they run that through the web map tiler to produce the mapping tiles. They've also done some tricky optimization things. You know, for the whole area of the EU, kind of 80% of the area is water, so they don't really need to do too much work there. So they kind of try and trim that out. What they're doing is they're taking these web map tiles and they're pushing them into a SQLite database. And really what they've got is just the tile scale, and the row and column, and then a blob with the image for that particular tile in there. And so that's where they're going to serve up this data from, are these SQLite, is the SQLite database. And then that's used to serve up, the web map tiles are used as background information for a whole bunch of different things that they're working with. One of the examples, I think we've just lost our internet connection, so I can't bring it up. But in this case here, some of the tiled information shown up, and then on top of that, they're showing, in this particular case, a public service for looking at where subsidized housing is. And so if you keep zooming in on there, you can see for each region how many subsidized housing facilities are there, and you can zoom in there. So you can go to that tiny URL and have a look at that later on. It's quite impressive how quickly that comes up and is served up out of those SQLite databases. So that's them doing very, very cool stuff at the state of Rioja. There is a full presentation of that if you understand the Spanish side of it. And they're hoping to see anybody out there who's live streaming in Barcelona. I guess they're going to attend our Barcelona event. And so from Ana Garcia and others at Rioja, thanks very much. So I think we're now going to break for coffee. Is that right? And you're going to say something intelligent?
Oh, we don't know. Wow, So you can start to see the scope of all the things that people do with FME, and we're anxious to see this afternoon and later this morning what things you're up to as well and during the breaks.
Yeah, because truly the hit of the world tour is being able to hear some of the solutions our users use with FME. And it's, just sitting and listening to them. I mean, some of the things people are doing is, as the guys who create this thing, it's pretty scary. And I know that was one of the things our developers too, when they talk to customers and see that they're doing, there's like, ooh, that's pretty scary.
Yes.
It's got to work. So
we're always pleased to see these things. So anyway, I think that we're going to say goodbye to all the folks at home.
Yep.
The people here, this is your chance to start putting up suggestions better than Don's.
That's
on
right.
The cool wall. And I see some that are rushing to do that already.
But if people don't, I get prizes.
You get all the prizes. Yeah,
That's
those
right.
shirts.
So
anyway, thanks for tuning in at
Yep.
home, and thanks so much for coming today here in Vancouver, and we'll see you after our 15-minute break. I thought it was Zemla in the back, but it's actually just cinnamon buns.
Okay. And if you're tuned in from the world, well, we'll see you on the road. So
Yes.
come to the world tour.
All right, goodbye.
Yep.